I found out that there is a
Recording is on.
there is an instruction that you send through nodes, through ROS nodes, that will pull all the nodes that they are not working. It's like a cleanup of the ROS core. And maybe while I was reading that, I was thinking that that may solve the problem in the simulator, because one of the things is that I have found out that when you do the ROS topic and the ROS node list, you found out that like there are some zombie nodes and zombie topics, and I think that with that instruction in the command line, you will pull them. I'm not sure if I'm being able to explain myself.
What is the thing that's resetting it, or what are we talking about here?
Oh,
Are you talking about ROS
yes.
purge clean? ROS clean purge? Is that what you're talking about?
No. Yes, it's an instruction. I don't have my Kindle here. I have to go to find it, because I mark it in the Kindle. But it was an instruction over the ROS nodes. Let me see.
There is a command.
Yes, it's ROS node.
It's what?
ROS node purge. PURGE.
Okay, all that does is delete your log files. So that's not doing anything special to ROS at all. It just goes out to your log directories and deletes them all if you run that. So if you do a ROS purge clean, that says delete all the, well, actually, it could be there's different things on, maybe I should look that up and see. But the way I do it,
it's ROS node cleanup.
ROS node cleanup. Let me go look at it and see.
Yes. Yes.
But I think that's something fairly drastic. That's not what you'd use on a running system to clean up or to terminate the navigation, I believe. So regardless of whatever it's doing, I don't think it's the I don't think it's what you want to solve the immediate problem.
No.
Debug.
I understand you. It was something that to try it the next time, because I have the same problem that Al has.
Yeah, I think everyone's going to have that problem, because I think you just have to tell the planner to shut down when it's done, and I don't think it's sitting there waiting for something else to happen. It's probably waiting for more. I don't know what it's doing, but I think you have to do something to reset you have to send a command to it to tell it to stop doing what it's doing, then it should be ready to accept the next command. That's my thought on that.
Yes.
And if you had to guess, Jeff, you think that command could be sent from anywhere, right? It's not necessarily
like a
Python
topic.
Programs.
It's like a topic you could send it. You could have a command line topic that says, it's like everybody's using that. They had something on the joysticks. If you push a button, it would cancel the current navigation. Whatever that's doing, I think you just want to do that same thing. So you could do it from a command line if you wanted to. Just put the thing on the command line saying ROS topic publish whatever the command's called to cancel navigation. That would probably work. And you could do it from, at any point. Just type that in on a command line and execute it, and that should do it. Otherwise, I'm thinking that follow path Python program, if it could send out the path once and then watch to see when it reaches the goal, then it could execute that and say, it could publish that topic saying cancel the navigation. I think that will reset it, and then you should be able to send it the next path at that point. Then I haven't tried any of this. I haven't verified that's even what it's doing, but I think that might work.
Yeah, I'll give that a try.
But we're actually talking about two different things here. We started off talking about running that generate points Python program to generate an actual list of points. And then Juan said, does that run in the simulator? Well, that's a totally different issue if it's going to run in the simulator or not. So that's something that, yeah, eventually, yes, that would, if you're going to run it this way, that would have to be fixed. Somebody would have to figure out how to get around that. So back to the original point, Al was showing his plots that he was trying to get it to generate a path, and then I generated a bunch of plots and put them out on Slack. And my question was, did people see those that I was creating?
I saw them all.
Yes.
Okay, so
Yes, I saw them.
So rather than having your plots you're confused with, we could pull up one of those that I did. I could say, here's why it works, and here's how you define it. If that would help. Here, I'll try to share my screen.
Sorry, I didn't understand the last part, Chef. Can you repeat it?
Well, Al was showing his plots and saying he doesn't fully understand why they work. And I thought, rather than trying to explain away why the stuff that he doesn't understand doesn't work, I thought we could pull up one of my plots that does work, and I can say this is why it works. So I'm wondering, would that be helpful to anyone if we do that?
Yes, it would be helpful. I'm trying to figure out how to program a ever reducing square. And
did you see my last ever reducing square that I posted last night?
No, I haven't seen that yet.
Wait a second. Oh.
I was probably in random, and it may have been buried in a thread. Since everybody likes to use threads, it makes it hard to find this stuff. But let me go see.
This one?
No.
That one I saw. That one I saw. That one I saw.
No, no. There is something. No,
Yes,
I have
yes.
this one.
And now I can't find anything in Slack, so I'm
Yes,
getting a little
yes,
disappointed in all the stuff.
yes.
It's not that. It's not
Yes.
that one. It's about 6 after that one.
No, but
Here, let me click on threads and see if I can find that one.
oh no, I have more. Yes. I see it. You are talking about this one.
No, keep going.
This one.
That I have not seen.
The one after that.
That's beautiful.
That
Yes.
one. That's what I'm trying
Yes,
to
I didn't see. Yes.
How the
Yes,
heck
I didn't see this one.
How the heck did you
So
do
does anybody
that?
want to hear about this?
Now where's the
The only way I can find it.
that's
Wait.
the that's the output.
If I go to
Wait.
Slack and I click on
Oh,
thread, I can.
That's the output. Where's the input?
No, I'm trying to share the link, but as a yes. Wait.
Just close
Like
this.
This.
Image.
Yes.
The number's right there on the message that we can't seem to find for whatever reason.
Yes. I
Which
put
you don't want the link to the PNG. You want the link to the message, which has all the numbers on it. Actually, you probably want both. If you go to Slack and pull up the image.
Yes. I got it. Now let me share it. Here. I put the link.
I'm trying to I clicked on it. I'm trying to see if it'll come up. Open Slack.
Doesn't seem like enough lines to generate all of those. Doesn't seem like enough rows to generate all those lines.
And that's why I thought it might be handy to talk about it. Well, I can't get that link to come up, but anyway, I can see it in, if I go to threads on Slack, then one of the first things that shows up is that particular message that we're talking about. And I don't know where I posted it because it's somehow buried in threads and I can't find it anywhere.
Mm.
Oh, so now it won't show up under Slack. So number one, I can't understand Slack and I can't understand Jitsi, so I'm not having a good day.
I think I'm the same page with Jitsi.
Here's one of my problems. I'm looking at the Ross Agriculture Slack, not the lawn tractor. Okay, so I'm back to the lawn tractor Slack. If I pull up threads and scroll down about 2 or 3 pages, there's that message. So it's got the numbers and it's got the picture. So if somebody can pull up that picture on their own computer from Slack and see the image, and then we can talk about the numbers. How do we get the numbers? Hold on.
Yes, let me do it.
Juan, just share your. I mean, I can share my Slack screen. I just clicked on the second link that Juan posted.
Let me share my screen and see if this works.
No, I put it in the chat.
Yeah, that's there. That's cool. Either way.
I see your screen.
You can see my screen now?
Yes, I see your screen.
Screen I can't see, but that's okay.
Yes.
So if we look at that, so down below, if you look at the actual image.
How did you get all of those lines with just whatever that is, 10?
So it's exactly what you were doing.
It is exactly what I was trying to do.
So if you look at the first line of code says 0, 0, 0. So that says we're going to start at a point. But what we're doing here, we're defining, let's see, you can see my cursor, right? So here's my cursor down here at 0, 0. We're defining this point, and we're defining this point.
Mm-hmm.
And then what we do is we define this point, and we define this point. So what you do...
Hold on just a second. Can you scroll down? I want to... That point... Okay, so that's 20, 0. I get it. Yeah, I see 20, 0 on the row.
And to make this entire thing work, you're defining 2 points to define a line. So at 0, 0, you say, I want to start at 0, 0 with a heading of 0. And 0 means to the right, apparently, in this context. So you say, we're going to start there with the tractor pointed, sitting on 0, 0, pointed to the right. And then you say, I want to go to the point 20, 0, still pointed in the same direction. That says when we hit that point, we still want to be going right at that point. So when it hits that, it's attempting to come through that at the same angle that we started at. Therefore, it'll draw a straight line between the two. Now, we did that, so we defined the start of the second row, and the start of the second row is the one at the top here, which happens to be 20, 20. But we're telling it when you get to that point, we want to be going the opposite direction. We want to be going to the left. So we have to swap. So from the bottom, we said come into it with a heading of 0 right there. And then we're going to turn it over to the software and say, I want to go to this point up here at 20, 20, but we want to be going the opposite direction. We want to go to the left now. So the Dubins planner automatically says, oh, if it wants to go from this point at the bottom to this point at the top, pointed the opposite direction, it just automatically draws this curve for us. It happens to be out 2 meters, and it's out 2 meters because that's the radius we have defined in the Dubins Path Planner software. Somewhere in there's a line that says radius equals 2. So what that does is, so what we're going to do, we're going to define these 3 horizontal lines and we define these 3 horizontal lines, and then we're going to let the Dubins path planner generate these vertical lines at the end. And they're going to, what controls the spacing on those is the radius that's defined into the Python program. So if you look at that, there will be 6 pairs of lines. Yes.
Yes, I don't want to interrupt, but can you mark with your mouse each instruction? For example, in the chat, the first instruction, the first row is 0, 0, 0. So I understand that is the first point, the initial point, and the second instruction, yes. Which does it? Okay. Here, it's there, and the first instruction. Okay.
So by doing it this way, all we're doing, we're defining horizontal lines. So we've got 6 horizontal lines defined. Let's start at the bottom here. This is the first horizontal line. Then we go to the top and we define this horizontal line. Then we go to the bottom, we define this horizontal line. Then we go back to the top again, we define this horizontal line. And we go to the bottom, then we define this horizontal line. We come back to the top and we define this last horizontal line here. So each pair in that set of numbers defines a start point and an end point. So we go up to this line, this is the start point, and this is the end point. So we come down the next line, this is the start point, this is the end point. So each pair of those is defining one horizontal line on the screen, and the vertical lines just automatically take care of themselves. Now,
okay. And the free 314, which for which accounts?
That is what direction you are pointing in the file, or in on our map. We'll call this a map, this graph that we've got right here. So if that number is 0, that means we're pointing to the right. We're pointing to the east. And if that number is 3.14, which is the same as 180 degrees, that means we're pointed to the left on our graph here. So that tells you on Dubins, you tell it 2 points, because you can make this do all kinds of fancy things. In fact, let me back up one. So again, I have no idea how to find any of this stuff because it's buried in threads. Here we're getting close. Oh, here's another good example to look at. See, if we use that same method I was just using, and let's see, can I make this bigger? So in this case, it says start at 0, 0, which is this point right here on this graph, and we say go to 7, 0, which is this point right here. And then I'm using that same technique we just had. No, this is actually the other method where I'm actually defining a horizontal line and I'm defining a vertical line. And the point is you have to say go to some point that's here's where you want your corner to be, but you can't go all the way to the corner. So you back off one radius from where you want to go. So again, the radius is defined in the code as 2 meters. So we go from 0, instead of going all the way to 10, we say go from 0 to, in this case, I went to 7. That, I guess this isn't the final example that worked right, but here, if you define just this much of it and then actually define the vertical line, you can drive right on that vertical line. So as I made, if we go back to the thing that nobody had seen, the comment after that says, oh, you could do the same thing with this technique and define the horizontal line and define the vertical lines, and then just do this little trick to make the corner work. So anyway, that I guess that wasn't the point I wanted to make. Let me back up one more here, if I can find this. Okay, this one. So here's another example that's going to confuse everybody, but this is the way it works. So if I say go from 0, 0, pointed in a direction of 0, that says we're going to start driving this direction until it gets to the point that we tell it. And the point that I specified was 10, 0, and 0. So if we go look at the graph again, so we're going to go from 0, 0 to 10, 0, and we're still pointed going right. So now what I do is I respecify that same exact point, but I tell it instead of going at a heading of 0, I want it to go at a heading of, what did I say, 1.57, which is pi over 2, which is 90 degrees. So basically when I say go here, go to the right, and when it gets to this point, I want to pick the same point but going up. So what it does, in order to get there, it says, oh, well, in order to do that, it has to start, Dubins uses either 2 curves, or it either uses 3 curves or 2 curves in a straight line. There's some combination. It always creates 3 segments. So what it does, it says in order to get there, it starts driving. It has to make a complete loop in order to hit this going into the right direction. So I'm going to go back through that same point, but at a 90-degree angle. So if you have the room at the end of your rows, you could do this. You could make this big loop around, which happens to be a 2-meter diameter because that's what's specified in the code. So I specified come into this at a heading of 0, and then pick the same point at a heading of 90 degrees. So in order to get there, it's got to make this big loop to go around there, and then it's going to come back in here and hit that point at exactly the right direction. So now it's driving vertically on this line. And then I did the same thing here. I said go to this point we want to come into this point at 90 degrees. So it drives a straight line till it hits that point, and then say, okay, now I want to use that, duplicate that point again, but put 0 back in as a heading. So again, to hit this point again at this direction here, it came in here and said, okay, what do I do now? So it says I want to go this way. I want to go in this direction at that angle. So it has to make this big loop around. So it comes back in and hits this point at the right angle. So you could define all your circles like that, but now you've got this big loop at the end of your corners that you're trying to do. So this thing down here, let's see how to get back to that. This one. This is one I was saying where we can do the same thing, but we have to add an extra. We have to add 2 extra points to what we're doing, or no, 1 extra point. So normally, if you want to go from 0 out to 10, if you do that, it'll draw the line out here. But then when you say to go to the one above, it's gonna come out this way and draw its 2-meter loop, and then generate its own vertical line. And the vertical line will not be on the one where we told it to be. So it will not be on the line that's at 10. It'll be on a line that's actually being out at 12. So if you drove all the way to 10, it would draw an arc out here to 12, and it'll put a line that we did not specify, but it will be 2 meters over because that's what the radius says. So this trick, you say, if I'm at 0 and I want to go to 10, I stop early. So technically, I could stop at I could actually go to 8 if I had it all figured out at that point when I was doing it. So I could say instead of going to 10, I'll just go to 8. So if I stop at 8 and then say I want to turn, and you can't, from 8, you can't specify this point up here because it's going to draw a stupid line at an angle like this. That's what Al was running into. He was specifying that and was drawing a line like this. So what you have to do is, once you get to this point at 8, you have to say, pick a point here at the beginning of this line. And when you do, it'll create a curve to that and come into it at the angle you want. And now it will then, from there, when it draws the next line, it'll draw a straight line right on the line that you told it to. And if I could find, later, in some of my other plots that I was plotting that we can't seem to find, I said, oh, by the way, here's how I modified that to the point where the trick is you just have to say second point that's on the second line, you just have to add some small fraction to it. Like I think I added 0.001, and that actually did it with just a single arc on top of that. So the bottom line to all this is, and I don't know where Slack put all this stuff, because I either put my stuff in random or in threads. And I don't see any threads showing up here that have the stuff in that I posted. So I don't know what happened to it. I don't know if it got totally lost, or I wouldn't put it in general, would I? So anyway, if you use the technique where you stop short of the corner, and then you specify a point on the next line. If you do this programmatically, that's just, you say go to this point and go to this point. It will automatically fill that in for you. So that's why I was playing with. And let me go back to my threads here. And again, just to explain how. So how do I get the one that was just before this one? Ah, 4 more replies. Here, it's buried in here somewhere. So here's what Al is doing. Let's see, can I make this? If I had this on a bigger screen, it would show up better on your screen. But so Al was starting off at 0, 0, and he said go to 10, and then he said go to this point. So that all worked exactly the way it's supposed to right there. So that came out. It created an arc of a radius of 10, or excuse me, a radius of 2, and now it's going on that vertical line. It totally made that line up. So it's driving up there, and it will automatically then connect with the second point going at the right direction. So it now starts the second horizontal line. But here he came to this point and specified this point. And so it's doing something strange, because what you should have done was you should have specified this point right here, and it would have duplicated what you had on the right. And then from here, from this point, then you say drive at an angle of 0 to this point and stop. Actually, you'd have to go right there, and then it'll do like the one I just posted. So here's how to get back. I said, oh, by the way, here's my first attempt at doing the spiral to catch your hayfield, which ends up looking like this. And this is showing that starting off at 0, 0, I go to 10, 0, and then I let it generate this whole curve right here for me. So here's my second line. And then I said, come back down to, like I said, Al should have done, come to this point right there, and it would have created that correctly. And then I just started repeating that. So see, each time I go on the thing, this part of the vertical line gets shorter until I get down to the very end. And this one, you see, is exactly, it creates one exact arc. So as the smaller you get, it gets down to the point where instead of putting an arc and a line and an arc, it now just draws one big arc, because that's exactly a 4-meter diameter turn to do that. And then you come down to the end here, and I said, well, I want to go to a row 2 meters away. It can't do that, so the Dubins generates the light bulb curve to make that turn. But if you do this in a big enough field, it doesn't do that to you. So you just have to keep track as your area to work with gets smaller and smaller. All of a sudden it does this, where it generates that light bulb curve. And one more interesting fact, if I were coming this direction here, and I specified this same point, but going the other direction, it will actually come out like this. It'll draw a curve, it'll come back, and it'll hit this same point and come right back going the same direction. And it figures all that out for you. You don't have to figure that out. All you're concerned about is the spacing between these horizontal rows here. And as long as that spacing matches the radius, then the vertical spacing will also match the whole thing. So that's the one where I showed. If there's anything else to look at here before I go back to that one. And somewhere here I'm saying that I've got this figured out. If you set it to radius and all that. So I swear I posted another one that showed that where I fixed that concept of where you stop early and turn. I had it down to the point where it's posting just a single arc, and that was working. So anyway, come back to this one. Come on. Oh, cut. Okay. So this one, damn it. So on this one, I've defined 3 horizontal lines. I defined this one, then I defined this one, then I defined this one, and then I defined this one, and this one, and it stops. Now, as these get closer together, when it gets down to the middle here, then it's going to do that light bulb shape turn at the end like I had. So you just have to keep track and decide when to stop. You could just have a thing in your code that says if spacing is less than radius, then stop, instead of instead of doing the light bulb turn. And the reason for that, I was thinking about why you do this on a hayfield, and I finally realized because this way your mower doesn't go over a row of stuff you've already cut. So if you've got stuff that's cut on the ground, you don't want to come out and drive over the top of these rows that you've already created. Is why you do it in a spiral as opposed to just blatantly turn it around at each end like you'd probably do on, say, planting corn. So if I back up as an example to this one, so on this one, it started off with a real nice spiral, but when I get to the very end here, see, this is now driving over the top of what you've already done, so that your mower would be going over the top of stuff you already mowed. And that may or may not be a problem. I'm not a farmer, so I don't know what that would do. It might just chew the hay up twice as much or whatever. So the point is, by just simply defining horizontal lines here, I can make it do this. And the other issue is, say, and right now, this only works if you have a rectangular field and it's a line north, south, east, west. So I was out looking at Al's. He's got the little fenced-in areas on his property, and they're basically a rectangle. One end of it has a little bit of a triangular shape to it. But the biggest problem is it's rotated like 10 degrees or something. So if you look at it from a Google map, you can see that his fence lines don't run north and south and east and west. They're rotated slightly, so that if you can get to the point where you can where you can generate this rectangular spiral, now you just have to say this endpoint starts at 0, 0, and this endpoint would be at some whatever the angle comes out to. You just simply specify that. So you can just simply rotate this entire thing by whatever angle you want, and still do the same patterns. You're just simply defining what I'm calling a horizontal row. It may get all the way up to, say, 45 degrees, but you're just defining one of the two. You're either defining the horizontal or the vertical lines when you go to define this. And then if you've got something on the end where it, say at this end, if the field was chopped off like this, like Al's is, then each line here, you say it started at 0, and you come around, this one would be out a slight amount, the next one would be out a slight amount, the next one would be out a slight amount, and that way you could actually adjust it to a sloped corner there. And if you don't do this by hand, if you just write a program that generates these, I think that would work fairly well. But let's see if I've got Al's map here. Let's say I don't know how quickly I can find this. I might have it in the bookmarks. I get Al's property bookmarked, and let me stop. Let me stop sharing. Hey, where did you get that one?
Can you see me? I'm using this. As you were talking, I was trying the things that you were saying in the sim, because that's the great thing about the sim, and I get the sim working. And I think that now I understand a bit more about this, because now I was trying the other 1.6. It's the one that
and that's not going to work because you're specifying you're specifying what angle you want to come into that point. And see, now it did something stupid to you. So you just have to understand what the Dubins stuff works.
Yes.
Because you can make this do all kinds of wonderful stuff as long as you understand the basic concept that you've got 2 points. You specify where the first point is, where the second point is, what angle you want to exit the first point, and what angle you want to enter at the second point. And actually, that thing that Kyler did, let me pull up his YouTube video. It's real interesting to watch it running.
Finish your thought, Jeff.
Oh no, sorry.
I'm trying to find the link to Kyler's video that's demonstrating all this stuff, and I can't. For some reason, everything's running really slow. So anyway, let me say D and Dubins. Okay, so let me go to this one. And let me grab the link. Copy that. I'll put the link into here. So if you go to that YouTube link, here's this code that's running. And let's see, can I share my... Oh, this Jitsi's going to drive me crazy. So I was sharing my screen, and then Juan shared his, and it shared right over the top. But now he went back, and apparently mine was sharing again. And now I clicked the share button, and it unshared it. So let me try this. Okay, now
we can use whatever you want. What would you like to switch to?
I have no idea how this stuff works. So, okay, so now this is a program. What's that?
I will let my Zoom account that I have a pro account that you can record the sessions, because I understand that maybe I want to record the sessions.
Well, okay, we can figure something out here, but I wanted to explain what this program is doing here. See this?
Okay.
If you go look at the his description, it'll say look at Dubins, or if you go look at the code for this, because that's a point back to his I think his website. And it says Dubins works by defining 2 points. And if you look at as this runs here, see the arrow says, here's the 2 points and what direction they're pointing. So what it does, it draws a circle of radius on top of that. And then it says, what's the shortest path? So it goes part way around the circle. And then it's going to draw, see, it draws a straight line. So it draws the first arc, it draws a straight line in the second arc. And this guarantees you always have the shortest path. And it guarantees that you're gonna, when you hit the new point, you're going the direction that you told it. So if you just sit and watch this for a while, it's absolutely amazing to see what it's doing. And he probably see, like right there, he's got 2 points close together. It had to make a big loop to get back around to do that. So anyway, if you watch that for a while, if you look at the Python code for that, I think it says I originally copied it from, and he tells where it came from. So somebody's got a description on how all this stuff works. But it's just down the point. You've got 2 points. You've got the point that you're exiting and the point that you're entering, and it figures all that stuff out for you. So that's why you can draw 2 horizontal lines. It will automatically connect those together at the end for you.
And this
so anyway, that's something you can go back and watch that and try to get a handle on what it's doing.
And that's the same concept that the package that we've installed is using the same concept.
Yes, it is. And it turns out if you draw 2 points and you say, you got 2 points like this, and you first one say, I want to be going this way, the second one I want to be going this way, it just draws a straight line between the two. That's how it draws the horizontal lines. And then when it gets to this point, still pointed this direction, but you say you want to go to this point up here, pointed that direction, then it does whatever it has to make this nice smooth curve to get to this point going in the correct direction. So it's generating all the vertical lines for you, and you're specifying where you want the horizontal lines to be. And by changing your spacing between the horizontal lines, and by playing with that radius value on there, you can tell it, like if you keep them equal, if you keep your horizontal spacing 2 meters apart and your radius is 2 meters apart, then it's going to it will automatically space your vertical lines 2 meters apart, and you're specifying your horizontal lines 2 meters apart. So on one of the messages on Slack, I said, so Al, do you know what the turning radius of your lawn tractor is? And then I said, do you know what the turning radius of your big tractor with a mower on it for cutting hay would be? Because that's what you're going to have to do if you figure out, what's the sharpest you can turn with your tractor with that mower on the back and not cause problems, and then take that number and put it in as your radius. And that way, then when you go to define this stuff, your rows will be that far apart. Well, actually, it's a little more complicated, I guess, because you want to set your row spacing based on how wide your mower is, because you want just a slight overlap as you go by each one. And then as you get the end, set your radius. And number one, it can't be sharp enough that you're going to bang into your mower as you turn. But then ideally, you want that radius to be the same as your row spacing. So as it makes its arc to come around and start going vertically. Let's see, so it comes down the row and starts to go vertically. You want that to, you want the spacing between the vertical rows to be the same as the spacing here. So it's just a matter of figuring out what that ratio is. But I think if you write like a Python program with 2 or 3 nested loops, you say, here's my start point, here's my radius / spacing, and it can generate that whole thing. It generates those points. You feed those as a waypoint file into the generate points, and it'll come up with those files like I did by hand there. Except then when you get to the point where your field, you've got a rectangle but it's rotated slightly, then you just have to do a little more stuff in your code to say, instead of making a horizontal line, the line has to slope up like this to get to the point. And so basically just your entire rectangle will be rotated like this. And like in the case where you have a rectangular field, but this end of it is at a kind of a weird angle, the first thing you do is just cut it off and don't do that triangle. And then the next thing you could do is each time you come back, just move your line. You know where that line is because the line goes like this at the end of that's where your fence is. So just your endpoints would have to be adjusted slightly. So the endpoint of those horizontal lines just has to move over a little each time. But Dubins is smart enough; it will then figure out the curve to get from one point to the other and follow along that. So that I think that would still work.
It's feeling closer.
Although when I go look at your big field, I look at your house and off to the right of that, you got this huge field, you got a tree line, and you got all kinds of weird shapes there. I don't know how you would go about doing that. So, and for inspiration, if you go look at the Ag Open GPS stuff, they've got a lot of this stuff figured out where they say, okay, here's what my field looks like, and you define these polygons, and it goes back and forth and figures out how to do all that. Now, the stuff I was looking at, they were doing like planting corn. So they would say, how do you break up this field into all these straight lines, and how do you turn around the end? But I don't know if it's got the spiral. I think they've got the spiral thing figured out too, that, you can look at that and he says, go to the screen, define these points, and boom, it generates all this stuff for you. So that's another place you can look.
Inch by inch.
So is anything more clear now than when we started?
Absolutely.
Yes.
It's huge progress. Thank you for spending time on it. That's fantastic.
So let me quickly tell you what I've been playing with here. So here's my power steering motor. Everybody should recognize this. Bob may not. He hasn't modified anything with the power steering motor yet. But I found at the hardware store, here's this piece of aluminum tubing that I bought, and it just coincidentally just fits right onto the.
Can you share your screen?
What's that? Can I share my screen?
Yeah, can you share your? Yes, share your camera so we can see the motor.
I can see it.
Oh, does it just show the J on your screen? Well, that's just because Jitsi isn't showing anything.
Yes.
So that's what the problem is.
I'm seeing your motor.
Now it's.
Let me try this just for the heck of it. Let me share something. And now let me turn it off. Can you see my video now?
Yes.
Yes.
Okay. Well, so remember that in the future, if your video is not showing up, somebody wants to see it, share your screen and unshare your screen, and that seems to fix it. So here's my motor. Here's the motor, and it's got the bottom shaft, has a knurled shaft that's like 16.5 millimeters or whatever. I bought this piece of aluminum tubing at the hardware store, and coincidentally just fits. I could just snugly fit it on there like that. And the outside of that happens to be 3/4 of an inch. So if you get a commercial sprocket like that that's cut to 3/4 inch, if I wiggle this hard enough, I can put that on there and put a sprocket on the end of my motor. Or what I was planning on doing, that's one approach. Come on. See, they fit well if they get stuck together. The other approach is I found a piece of electrical conduit, and I was going to put this over here and drill a hole to pin that on, and then my shaft for this is the shaft for my steering wheel, and it's already got a hole drilled through the side here. So a hole drilled through the side, so I'll put it in here, and then put another bolt. So I got one bolt here to lock these two shafts together. But the problem is, if I show, as I say, these fit real snugly. So if I do this, everybody's still on. Everybody's video disappeared, but
still here.
So I've got that much room between those two. So I think because when I wanted to buy a pipe like this pipe to tie the two together, I can't find the one that's got 3/4 inch inside diameter. I can find them as 0.83, which I think is like a 1/16 of an inch bigger. So if we look at the end, it's that much. If I hold it against the side, that's how much I got. So I think what I can do is just take like electrical tape, put a few wraps of electrical tape to get this out to the same diameter as the inside diameter in this one. And since this, it just so happens the outside of this one happens to be exactly the same diameter as my steering shaft. So I'll put tape on both of them until I get to the point where it just snugly fits on there. So that'll get rid of the slop that I've got like this. So I think I just put some tape on there and that'll shim it out enough to be solid, and at least long enough to go ahead and drill a hole here and drill a hole here to get those to line up. And that's kind of where I'm at right now, trying to figure out how to get those two shafts locked together. And I think I decided this is electrical conduit, so it's thin wall tubing. And it turns out that if I get water pipe, like steel water pipe, I think I can get the same inside diameter. It's like 2 or 3 times the wall thickness. So I'll test it with this piece of conduit I got right here. And then if it works, then I can spend my $2 or $3 and buy the piece of steel pipe at the hardware store and re-drill it and do it that way. But then I still have the problem that once I've got this motor like this mounted up on top, and here's my steering shaft, and I've got those tied together with some kind of a coupler there, I still have to have someone to physically mount this motor. And I saw on Juan's lawn tractor, he had some kind of a steel bracket that came up over, so I assume he bolted on either to the frame or the side of the housing, and then somehow used, because you got these holes in the top to hook onto, and you got this big thing across here you put a bolt through, and then where I took the controller off,
I'm not seeing your screen, and I think that I want to see your screen. Can you share your screen with me?
Let's see. Is that because Bob just posted?
I'm seeing your screen.
Okay, so
I'm not
again, it's
seeing
just
it.
random. Here, I'll do this trick again. Okay, so there's back to my shared screen. I unshare it.
Yes.
Okay, can you see me now?
Yes,
never
I
lost
see
your
you.
screen.
Yes.
Okay, so anyway, so we're back to this thing where I say we've got the motor like this, and here's my steering shaft, and I can lock those together with a piece of pipe. So then I have to figure out some way to keep, right now it'd just be hanging in free space. So I have to either use put a big bolt through here, or I've got these two small bolts here where the controller is bolted on. You can use that, or it's got the 3 on the face that I can bolt onto that somehow. But I need to make some kind of a bracket to keep. So number one, this thing is going to be on top of the shaft like this, and I just have to have some kind of a bracket to hold it there so it can't rotate and can't fall off, basically. So that's kind of where I'm at now with that, just to see what that does. The other option I had was my steering shaft comes
Let me
up.
say something, Chef.
What's that?
When you are trying to, there are 2 types of a scenario when you're working with that. The one that you are testing when you have your wheels up, not on the floor, so it's so loosey that you can use it. You can use everything to work with the steering wheels. But when you put the tractor on the floor, that will get heavy and you won't be able to use the same things. Maybe if you get some duct tape and you catch it, you can use it while you are testing, and that will be okay for a lot of time. But when you try to use the other thing, you will have to go with the bolts.
Yeah, I understand that. Eventually, I should just figure out how to bolt it on there solid. So another thing I was thinking about, so here's my steering wheel shaft coming up through the thing, and it's about that angle, and then normally it just has the steering wheel stuck on like this. And it turned out originally the bottom of the steering wheel was right against the plastic housing, and I looked at it, and it turns out there's a like a block of plastic sticking up like that, and I just took an angle grinder and cut that out of there, so I got a big square hole in the top, and I've got access to it. So it's like this with a steering wheel on it. So if I pull the steering wheel off, I could put a sprocket onto that where the steering wheel was, and then have mount my motor down below like this, and just sort of chain between the two. So can't get the right angles here. So basically just mount this motor on the front of my plastic housing and then just run a chain. So that's going to turn the existing shaft. And I could probably, I think I've moved it enough now where I could put the, leave the sprocket right there and then put the steering wheel back on. So it's got, I think I can get it just to fit just like that. And that would give me the advantage that if I want to, I can still turn the steering wheel and overdrive the power steering motor. As long as the power steering motor is not powered, I think I could still run it that way. So that would be, and the motor would be down between my legs if I'm sitting on the seat. So I think that would give me the advantage that if I had to, I could still get on and manually drive the thing around. So that's something else I'm going to think about. And as slow as I'm working on it, it's going to be, you know, probably several weeks before I get anything to work. But that's a couple thoughts I had. And once I get to the point where I think I can manually, once I think I can mount it, and I'll bring the motor back in the house and put it on the table and hook the motor controller up to it and write some code for it. So then basically if I just go bolted on, then I could specify the steering and hopefully it'll control it. So, but that's what I've been playing with just here recently. So that, and I went and looked at that Dubins path planner a little bit to figure out that stuff. So I think
Chef?
Yeah.
I want to ask you some questions because while I was working with the steering wheel, I found out that the steering wheel has other wires that I'm not sure which are the functions. But maybe do you know for what you can use them? Because I thought that maybe there was a potentiometer inside the motor or the steering wheel that I can use in the tractor. You found out something about that?
Your lawn tractor has extra wires on the steering wheel?
No, wait me a second. I will pull out my motor and I will explain.
You're talking about the steering motor. Like for instance,
yes.
Even these wires coming out. This is not on the GM style motors. This is not an easy thing to use these, and also it's not going to give you an angle. It's just telling the difference in torque between one shaft and the other. If you try to twist the shaft, it's just telling you how much that's twisting it. So I would say on the GM ones, no, you can't use that if that's what you're talking about.
Yes. Yes. The one that I have here, it's only have the red and the black wire. The one in the tractor is different.
Yeah, so I was just holding this up, I don't know if you saw that, but see, mine had the controller bolted on right here, and then these little wires went into the controller. But that's just telling you, that's measuring the torque between the top shaft and the bottom shaft. That does not give you an angle. So it's not.
Okay.
But for what I see, this is not, for what I'm doing, this is not usable for really anything.
I was asking that. Thank you.
So what I'm going to do, if I bolt this straight onto the shaft like this, boy, that motor's heavy. If it's straight on the shaft like that, then I'll do, I think what you did, on the top of the shaft, you put a potentiometer into here with a little bracket to hold it. So that's how I can measure my feedback right there by using a potentiometer or one of those little Hall effect things that looks like a potentiometer. Or if I mount it like this and then put the sprocket on, I've got, say, this sprocket going to here, what I could do, then that leaves the hole up here available for a potentiometer, or I've still got the hole in the bottom for a potentiometer. And then also on mine is built differently than the Cub Cadets, and maybe that's why Juan's is built. But mine has a shaft, like a 3/4 inch shaft that goes down through the bottom of the frame, and it's got an arm welded onto that. So instead of having that big half moon gear with the two connecting rods, mine has a single arm sticking out. It's about that long. So here's the shaft. Where did my shaft go? Oh, I dropped it on the floor. So it has the shaft sticking down through the bottom of the lawn tractor, and it's got a metal plate welded on that sticks out here, and then I just had a single control rod that goes from here to my front end. So if I had it like this, here's the arm sticking out, the control rod connects here, and this runs up to one of the front. I think it hooks to my front left wheel, and then on mine, it's got a control arm from the left wheel directly to the right wheel to do the Ackerman. So what I could do is, since I got this arm that moves back and forth like this underneath the tractor, I could take one of those little what everybody always calls a ride height sensor, the Delphi ride height sensor. I've got some that's a different brand that actually came out of a Corvette to measure the headlight angle or something, but it's essentially a little. Oh, something just happened. I think we're viewing somebody's screen, but I guess it doesn't matter. Anyway, I've got that sensor. It's a Hall effect sensor. It's got an arm sticking out, so I can connect the arm of that to that one arm that moves back and forth that I was just talking about. So I could get. I might do both, and that way I could, back to my concept. I like to put on 2 or 3 things and then select which one works the best. So I can put that on underneath to read the angle, and then I can put a potentiometer on the motor to read that angle. And there may be some other things I might want to dig into also. Is that Bob's? Whose is that?
Say again?
Whose screen are we viewing here?
I see 3 tiles, but I don't see anything else.
Oh, I'm getting somebody's screen. I'm guessing that's Al, since it's got a 3D printed disc on the steering wheel.
Okay.
Can you see my screen?
Yes, I can. That's what I was asking about.
I don't see nothing. It's totally blind.
I just see Al. I see the letter A
Huh. That's odd.
and a black screen now.
And a black screen. I'll be darned.
So
Let me
I think
stop
we just lost
sharing.
one.
Try
Al,
that again.
You're recording it, right? So maybe I could look at your recording.
That possible, yeah.
Yeah, I'll do that.
What do you see now?
So what we have, we've got a steering wheel on a tractor, and now the audio is weird. So he has 3D printed an adapter that goes on top of his steering wheel, kind of like your piece of plywood that's bolted to your steering wheel. And he's about to explain what that is and what it's doing.
Yeah, so I'm just, I don't know if, Jeff, if you could do that with your setup, but that's what I do with my tractors. I'm able to mount a bracket that holds the motor above the steering wheel, and then have an adapter that sits between the motor and the steering wheel. So
Yeah, I might be able to do that.
And I don't have a handy picture to show the bracket and the motor that sits above it, but that's how I've been able to get it done with.
And Bob is doing the same thing on his. He has a piece of plywood screwed to his steering wheel, then he's got a DC motor that turns it from the center. So he's basically doing the same thing you are with different parts. And I'm not sure I would try that. I'm going to proceed with a couple things I got right now and see what I can come up with.
I'll dig up a picture of that steering wheel and post it later.
Okay.
Okay, guys. Well, we've run over a little bit, but
do you know what you're going to do with that recording if it works?
I'll put it out on the way this saves it in Dropbox, but then I'll move it from Dropbox into the Google Drive somewhere.
Okay.
Okay. What it's done, just give us a link so we can check it.
I'm sorry, Juan?
Yes, thanks, Jess, for the explanation, because it was very useful. I will play this weekend with this, and I will try to run the path in the simulator.
And I'll copy this chat into the Google Drive as well, since it needs to be saved off as well before we leave.
And a couple of things before we leave. I wanted to ask Bob, did you get my email I sent you last night about the COVID vaccines?
I didn't look last night.
Oh, it's actually not an email, because last email I sent you bounced, so it's either on the lawn tractor automation Slack, or it's on the Ross Agriculture Slack. I think it's on the lawn tractor automation. You should have a private message there.
Okay, I'll take a look.
Just to be brief, Minneapolis is receiving COVID vaccine. If you register at Walmart, you can get an appointment for next week to get vaccinated. You have to be 65 plus, which I assume you are.
Oh yeah.
So I'm registered for next Thursday, and I want you're one person I thought of could take advantage of this. And if you're going to do it quick before all the slots are gone. Right.
Well, thanks for the heads up.
And the other thing I wanted to bring up was I sent something to Al saying he always seems to be confused on trying to run the difference between the simulator and the physical tractor. And I said we could go through that sometime and figure out how to do all this transform stuff. And the bottom line is, if you want to run the URDF file, you have to have a URDF file for the simulator and one for your lawn tractor. So you have to copy it and hack it to make it match. But we can go through that sometime if people want to do that. The other option is what I usually do. I just write static transforms. So I don't run a URDF file on my physical tractors. I just put a line that says the GPS is here, a line that says the camera is here, and a line that says something else. And you can make it work that way also. But to make it more compatible with the simulator stuff, you can't run the simulator URDF on your physical lawn tractor because they're not the same vehicle. So you just have to copy it and modify that. And we can go through that either on one of the meetings or whatever.
Got it. Thanks.
Good deal. Thanks, guys. I'm just going to make sure that I've got the chat saved off and then stop the recording and then sign off.
Is there a button to save the chat, or how does that work on this?
I'm copying it off into a file and putting it in the Google Drive.
Do you just cut and paste, or is there
I'm copying and pasting it into a folder under lawn tractor automation video conference chats.
Okay. It's just that on Slack, there's a button that says, click here and says save chat, and it puts it out there for someone for you. So I was just wondering if this sophisticated piece of software has a button that does that, but I don't know.
Haven't found that. I'm low tech. I'm a analog guy in a digital world.
Okay. Well, that's all I got.
See you guys.
Okay, bye.
Thanks a lot, guys.
See you, Bob. Some of that might